schedule programs or processes to be run on our computer and allows us to run them in an automated fashion unattended and have the results of those processes reported to us as a consequence. So we'll label this section Cron, and it features standard Unix job scheduler, which allows us to run processes at various intervals, perhaps repetitively, is ideal for repetitive jobs, but may also be used to run one-off jobs or to run batch jobs. So it runs jobs using its job scheduler, and that job scheduler can be configured to execute jobs based on criteria including minute, hour of the day, day of the week, month of the year, and year such as once per year, for example. So monthly, daily, hourly, minutely. Cron allows us to define jobs, and these are 5 distinct fields that are specified on a per job basis from left to right, as indicated here in this particular order. So let's just note fields A through E are specified as per the order above in appropriate configuration file. So the first thing to wrap your thoughts around is the units of time with which we may schedule processes, such as every minute and so on. Now, one of the things about Cron, which you may call a feature, and also you may call it a caveat, it's that it assumes that your computer is always on. Now, in the case of Linux and Unix-based systems, that may be largely true, but certainly there are times when the system is currently unavailable due to power outage or scheduled downtime. So it assumes the computer is always on, and as a consequence, it's unlike Anacron, which can run processes in the event that your machine was off when it was supposed to run a process, which we'll be looking at in the subsequent section. So again, Cron assumes that it'll execute its schedule within your system or on a system that is always up and running. And typically for Unix and Linux systems that is the case, but there are times when your system may be down when processes should have run that Cron will not process, and in those cases Anacron will be able to help you to process those jobs. Now, in addition to those features, Cron maintains global and per user schedules. This means we can configure jobs as the root user from a system level, which should apply to the entire system, such as backing up files, for example, on a regular recurring basis, or on a per user basis, such as the calculation of processes for a given engineer who connects to your Linux box. So per user and per global or global schedules are maintained via disparate config files, which we'll be looking at. Cron jobs are maintained beneath var spool cron. So this particular directory stores the cron tabs or cron tables for users that are defined in etc password or LDAP or otherwise. So when those users of your system, let's say the user Linux CBT creates a cron tab entry, the entry is maintained in var spool cron on a per user basis with permissions that are accessible only to root and to the owner of the cron table. The table is just, again, a text file which includes the schedule and the job or command to run, and it may contain one or more of those items. We should also note that Cron wakes up every minute, so checks all config files every minute, including, but not limited to, the Anacron file, which is located in etc, which is a different table managed by Anacron. So it checks all of these files, per user, global, and a cron tab, every minute for changes. And if changes are detected, then the new schedules are submitted to cron's memory and executed accordingly, which means cron runs as a daemon. So it's always running as cron D. It also supplies a utility which allows users to maintain their cron tabs. So supplies cron tab utility to manage jobs. Super. So let's get into some of the jobs that are defined and into defining some new jobs. So our tasks will include 1. Analyze current cron setup. So there are a number of things to check. First, let's take a look at the process listing using psef grep cron. That will reveal the process that's running cron D, which wakes up every minute in search of new work to do and executes that work accordingly. Now, any user may query the PS table, but since we're logged in as root, let's execute it as root. And this is the process cron D that runs perpetually. And if we RPM grep cron, we'll see momentarily the process the package that the process is tied to from the RPM database, and that's cronny. And if we RPM query list cronny, we'll see the contents of the package, which gives us an inkling as to the various config files, binaries, and so on that are used by the package. Now let's go ahead and RPM query list cronny, and this includes key config files and documentation. As you now know, we can also examine just config files used by the package. So cronny will process cron.deny, which is a way of restricting users so that they're not able to run jobs via cron, so that if you specify users in cron.deny, those users will not be able to submit jobs to cron. There's also an entry for PAM integration for authentication purposes, and a sysconfig cron D entry, which contains global settings for the daemon, which we'll be looking at momentarily as well. And we also see inside of etc a cron.d directory, which contains a number of items, including 0 hourly, or items that are to be processed on an hourly basis, as well as potentially others such as daily, monthly, weekly, yearly schedules. So that's the main cronny package. Of course, it provides the sbin cron D binary, which is always running, which means it is invoked via etc init by upstart as cron D. So this is the start script, which also means a service cron D status should reveal that it's currently running with its PID, which can be confirmed with PS, of course. So that's the nature of cron with respect to how it runs and looks out for jobs that are to be processed. Now let's examine the tables that are processed by cron and manipulate some of them. So we'll take a look at etc, and let's go back to, it's going to be etc cron tab. Let's go back to our shell to take a look at that. Let's navigate to etc. And if we tab out cron star, you'll see a number of items. Now, you didn't see these items within the cronny package because they are or were placed there by other programs, like in the case of Webalizer, for example, 00 Webalizer. So inside the etc directory, we see cron.deny, which is empty, which means everyone on this system may submit jobs to cron, and it'll run those jobs accordingly. There's a main cron tab file. It's only 448 bytes. And in cron.d, we see 0 hourly, systat, and then in cron daily, these are jobs that run every day. This is a job that runs every hour. It's an anacron job. Here is a monthly job, and here is a weekly job, which does a RAID check. Let's cat the contents of cron tab and discuss this file. It's already heavily commented, at least in this version of Red Hat Enterprise Linux, which makes it easy to follow, or easier to follow. It includes some variables that are processed or incorporated by every job that executes under the auspices of cron. So if a job's run, It'll include this shell, bin bash, which means it'll run under the auspices of bash. It'll also include the following path. Any errors or successes will be mailed to root, and the home directory is the root of the file system. Now, in particular, this pertains to system run jobs. You can manipulate the same variables in your own cron tab entries for non-privileged users by including them as part of your job definition or as part of your cron table. Now, on to the more important section of this file, and that surrounds the breakout of the job scheduling, the time increments. So notice it's heavily commented, including what the 5 fields mean. So the first field means minute and can be a value of 0 through 59. Since it's already commented, no need to specify it, which means we can indicate the 0th minute or the last minute, the 60th minute of the hour, or the 59th, which leads up to the 60th, which starts a new hour. Hours may be specified as 0 through 23, which covers 24 hours. Days 1 through 31, which covers all of the months. 1 through 12 for months. 0 through 6 or 0 through 7 for days of the week. If you use 0 or 7, they both mean Sunday, which means the other days mean Monday through Saturday. So when specifying a job, you are to use this framework in laying out your schedules. Now, you don't need to specify hard values for all of the fields. For example, if you'd like your job to run any day of the week, then a wildcard in any day of the week would allow your job to run any day of the week. Wherever there's a wildcard, that means your job applies on that particular or for that particular item. So a wildcard for month means your job applies to every month of the year. Whereas if you specified a range such as 1 through 3 in the month field, your job would run January through March. Same thing for day of the month. So an asterisk or wildcard means it can run on any day of the month, but you can also restrict it or specify steppings such as every second day or every 10th day, for example, or every 20th day. Same thing for hour. Perhaps you'd like your job to run 4 a.m. or perhaps 3 p.m. You can specify it here, or you can specify a range. And you can also control the minute with which your job runs. And you may also influence a stepping on minutes to cause your job to run, let's say, every n number of minutes, every 5 minutes, 3 minutes, 2 minutes, so on and so forth. So this document's already commented to give us a sense of the scheduler. So that gives us an opportunity to define a job. So we can run a simple job, perhaps something that runs a little process like uptime, for example. Something very simple that will produce some output. So another task. Define system-wide job. If it's a system-wide job, the simplest place to place it, if it's not going to run, let's say, once daily or monthly or weekly, is simply in etc cron tab if it's system-wide. So we'll be modifying etc cron tab. So supposing we'd like to have a job, let's say, uptime, run and send output to root's home directory. We could simply include an entry that resembles the following. Supposing we wanted the job to run every minute. So in the first column, and the single quotes are not to be included, we'd include an asterisk, but because we want it to run every n number of minutes, we'd use a /1 to divide the first column into every one or first or additional minute. So every 1 minute, run the job. Then we'll continue every hour, so this should happen for every single hour, every day of the month, every day of the week. So those are our 5 fields spelled out. Now, we need to specify the job. Now, this is where you normally reference a script or the command itself. Now, when defining cron tabs on a per-user basis, you don't need to specify the username. But when you do on a system-wide basis, you should specify the username. So here we should specify the user. Let's have the job run as the user Linux CBT. And then we'll specify the command. So the one slight difference between the system-wide job and the per-user job is the specification of the user with which to execute the job. But you don't have to specify it, because as you see in this example, you can indicate the schedule followed by the command. But optionally, your system cron tab can include the user with whom to run the job so that you know to whom the job belongs. So let's take a look and we'll have Linux CBT run the uptime command. Now, it always helps if you specify the fully qualified path. That way there is no confusion. So let's look for uptime, and it's in user bin, which is a path that's included by default in Cron Jobs, but let's just be sure by prefixing it with user bin. And then we can send the output perhaps into the user's home directory, home Linux CBT, and we'll simply call it uptime.stat, for example. So this is a simple job that will run every 1 minute during our discussion. So let's place this into the system-wide cron table. And we'll paste this in this area. Any line that begins with a hash mark is a comment, so we'll include this as a comment. Temp job for classroom user. Now, once we save the changes, at the next minute, when cron wakes up, so in roughly 40 seconds, when cron wakes up, it will have seen that etc cron tablet status has been changed. Relative to our current time, it was changed at 15:09 and 15 seconds with n number of nanoseconds precision. So it'll know that there's been a change, and then it will cache the new etc cron tab settings and be prepared to process the job. Now we'll see if it runs immediately at the next minute, which will come in 11 seconds, or at the